Why should farmers choose no-till? Most people do not realize this, but farmers provide things like clothes, food, and biodiesels for the world. Farmers would not be able to do so if it wasn't for farmable soil. This problem affects the whole world, but especially farmers. The way farmers handle the soil impacts everyone's everyday life. Farmers want to be able to preserve the land for years to come, as well as increase their profit margins. After research, it was found that tillage is a way to prepare seed bedding for the next growing season. With each growing season comes planting and harvesting. This often causes destruction of the soil, which tillage is a contributing factor. How farmers make the soil last for generations is a very controversial issue. It was found that conventional tillage is the worst practice for farmers to use. Conventional tillage uses equipment that goes deep into the ground and overturns the soil. Minimum tillage only turns over a few inches of the topsoil, and no-till does not turn any soil over. The way farmers preserve the land is the most important process in agriculture because the soil needs to last for years to come. Different tillage practices also create different amounts of weed pressure. When weeds sprout, they take up water, light, and nutrients, and can be very hard to control. No-till can use water more efficiently, help compaction, increase the weed pressure, increase soil quality the most, and save time and money. First, no-till uses water more efficiently than other tilling practices. With crop residue on the surface, it slows down the water and allows the water to move through the soil instead of over top. The article Soil Water Content Maize Yield and its Stability as Affected by Tillage and Crop Residue Management in Rain-Fed Semi-Arid Highlands introduced the benefits of no-till. These authors believed no-till was the best and had a strong argument on preserving the soil and increasing yields. Tillage operations move moist soil to the surface, which increases evaporation, whereas no-till leaves crop residue to conserve not only water, but reduce soil temperature. With the extra water, it increased yields up to 1.5 milligrams per hectare. No-till improves water infiltration compared to conventional tillage due to the residue cover that slows down runoff. This article helps the argument that no-till is the best. Tilling moves moist soil to the surface, increasing evaporation, whereas conservation agriculture can improve the water content and help buffer mid-season droughts. This article had data showing no-till yields were equal or higher than minimum tillage compared to conventional tillage. Another article was the importance of hydrophysical characteristics of the epoch coating and substitution of conservation's tillage systems. Argued that water has an imminent effect on yields and different tillage practices will affect the percentage of evaporation. The article showed that the significance of no-till technology, which is being applied globally over 100 million hectares under most diverse climate and soil conditions. Some recent no-till technology examples are the recent discoveries of cover crop and machinery such as the aerator being used. No-till can significantly contribute to reducing the amount of water needed to develop a given crop. The reduction of the water runoff and consequent reduction or avoidance of the soil erosion in the crop residue covering the topsoil create a favorable environment for a significant increase of biological activity. This further improves soil and general agro-ecosystems function. One opposition is that minimum tillage, such as the chisel plow used in the fall, does not decrease yield. Even though minimum tillage does not decrease yields, the tilling process leaves the soil susceptible to erosion. Minimum tillage also uses the extra time of being in the field along with the diesel it takes to pull the equipment. Second, no-till helps soil compaction, and that can cause decrease in yields for many reasons. This article, Soil Compaction Influence on Winter Wheat and Soil Physical Properties, explained that soil compaction was the different effects of tillage practices. Soil compaction is the physical consolidation of the soil applied forces, such as heavy machinery running through the fields. This will decrease yields. This test used for the equipment was a pyrometer that measures soil strength. The test was focused on soil compaction over water quality in the soil. Also, yields were equal or higher using conservational agricultural practices compared to conventional tillage. One opposition is that no-till uses no type of equipment to break up the soil after each harvesting season. Applied forces over time can cause compaction. With tillage, this is also said to prevent compaction, but instead the compaction just occurs lower in the ground. When compaction problems arise in no-till, farmers can use cover crops to break up the soil below. Cover crops include grasses, winter wheat, rye, radishes, and legumes. These are winter annual plants that can survive the bitter frost in the winter. They grow late fall and continue early spring. Their roots are used to break up soil compaction by their root systems. Cover crops seeds are flown in by planes, allowing less travel through the field. The more a farmer drives in the field, more compaction occurs. One way farmers manage crop residue is using an aerator. This cuts the corn stalks, speeding in the nitrate process. Nitrogen is an important part of a corn plant process. No-till or zero tillage is a farming system in which seeds are directly deposited into untilled soil, which has retained the previous crop residue. The no-till system changes the structure of technological elements through less soil works. So the impact on the third no-till helps with weed pressure. This is because the crop residue that no-till leaves covers the ground, so sunlight cannot reach through the soil. This makes it hard for winter annual weeds to grow. When the farmer plants his crop, he uses a planter with trash whippers that clears the crop residue for each row of seeds. This allows the crops to get a head start by taking up light and they need before weeds get it. Fourth, this next article addresses tillage practices that affect soil and how to maintain soil quality. Cultural practices to maintain soil quality said no-till with crop rotation is the best. Tilling the soil robs the soil's nutrients and organic matter and reduces crops' yields. It mentioned that no-till improves soil quality and that rotating crop weeds diseases. It's a system that uses soil, water, and nitrogen more efficiently. Increasing soil organic matter reduces the risk of crop failure from droughts and uses less nitrogen fertilizer, up to 20 pounds less per acre, says O'Brien. This is big for recognizing the benefits of no-till. No-till is more eco-friendly because it produces fewer emissions from tractors, as O'Brien states. 25% of human-made carbon dioxide and 70% of human-made nitrous oxide being released in the atmosphere are from farmers. This is a practice of leaving the soil the way it is after harvest. No-till conserves soil, water, and reduces soil erosion, and increases organic matter compared to conventional tillage. Also, the soil has millions of microbes per foot, in which the article addresses the importance of these microbes. When we destroy the microbes' environment, the production rate also slows. Microbes break down minerals that plants can use. Anytime a farmer is driving machinery in the field, it destroys the microbes' environment. Farmers are now trying to learn how we can restore this environment, and some methods are conventional tillage, minimum tillage, or no-till. Another article was Tillage Effects on Soil Structure and Grain Yield of Maize, explained one of the most important negative consequences of modern agricultural production. Soil conservation tillage is intended to leave residues on the soil surface, and it has become a recent practice. The physical degeneration, which is attributed to deep intensive tillage practices, results in erosion and soil compaction. Compaction causes deterioration of soil physical properties, evidenced by increasing the bulk density, penetration resistance, high specific resistance to soil tillage operations, and reduced soil structure stability, which direct impact on yield, fuel consumption, and production costs. Fifth is no-till can save the farmer's time and money. With one less pass through the field, the farmer can save a lot of time depending on the amount of acres he or she farms. Also, no-till saves money. It takes big machinery to rip through the field that a farmer will not have to use. also to fill up big tractors with diesel that cost lots of money. In conclusion, most of the articles had strong arguments towards no-till being the best agricultural activity for farmers for the soil. Farmers have to preserve the land and get as much use of the soil as they can. To do so, there are three practices a farmer can use. Conventional tillage, which turns deep soil over, minimum tillage that overturns the top few inches of soil over, and no-till that leaves the crop residue on the surface. After researching, it was found that conventional tillage is the worst. The article shows that no-till was the best option for farmers because no-till uses water more efficiently, helps compaction, increases weed pressure, and increases soil quality the most, and save money and time. An example of minimum tillage equipment would be this disc, and it takes a lot of fuel to run this tractor, and so you're saving time and money without having this equipment for minimum tillage.